Hello students, welcome to SmartKidz tutorials. In this video we'll be solving the second question from exercise 9.2, which says if E, F, G, H are respectively the midpoints of sides of a parallelogram ABCD, show that area of quadrilateral EFGH and area of quadrilateral ABCD are equal to each other. So this is E, F, G, H. Okay, and the other quadrilateral that we have is A, B, C, D, and we are only given that this E, F, G, H are the midpoints of this sides of the parallelogram. What we can do over here is we can construct a line over here connecting H to F. I'll put it as a dotted line showing it is a construction. So we mark over here construction, join HF, we say. Okay, now that we have done that, we put over here such that HF parallel to DC, and you can also say HF parallel to AB. So which means it continues to be a parallelogram. In fact, it forms two parallelograms now. Okay, if you have a look, HFCD and the other one will be ABFH. Two types of parallelograms will be formed over here, because this is line HF is also parallel. It's parallel to DC and also to AB, and we know that AB is parallel to DC because it's a parallelogram. So let's utilize some of the properties that we know and the relationship we know between triangles and parallelograms in this problem or question. Okay, so we say over here solution. So you can say HF is parallel to DC. Okay, HF parallel to DC, and you can say this is like by construction. This is not given, this we have constructed, so we have to say by construction. And you can say triangle HFG here, HFG, okay, lies HFG, and you can say and parallelogram HFCD lie on the same base, that is which on HF, and between same parallels. Okay, that is HF parallel to DC. Therefore, then we write the relationship. When a triangle and a parallelogram lie on the same base and between the same parallelograms, we know that the triangle which is there, area of that triangle is half of the area of that parallelogram, as we have done in the our second video where we learnt about the second theorem. Okay, we learned that the area of triangle that we get is always half of the area of the parallelogram. So we write over here area of triangle HFG is half of area of parallelogram HFCD. I mark this as 1. Similarly, we can put over here similarly. Okay, we can say area of triangle HEF is also half of area of the parallelogram. This time we take HABF. Okay, so why is that? Because we can write over here, since triangle HEF and parallelogram HABF share a common base, and that base is HF, and lie between same parallels. And which are those parallel? HF, you can say that is HF parallel to AB, and that is by construction. Okay, we've got over here HF parallel by to AB by our construct. So you see the relationship when a triangle and a parallelogram share a common base and they lie between the same parallels, then the area of the triangle is always half of the area of the parallelogram. Or we can conversely we can also say that the area of the parallelogram is twice the area of the triangle. But this relationship is good because we are interested in only getting area of one parallelogram equal to the area of the other parallelogram or the quadrilateral. So and we'll mark this as 2. We say adding 1 and 2, adding 1 and 2. What do we get? We'll get area of triangle HFG plus area of triangle HEF equal to since the half and half is common, I will just take half outside and say area of quadrilateral or parallelogram HFCD plus area of quadrilateral HABF. Okay, so this is what we get when we add the two up, and I've taken half common to both of them because both have half, so I've taken the half outside. Now if we have a look, what is triangle area of triangle HFG, and what is area of when added to area of triangle HEF? What is that? See, area of triangle HFG is what? This part, and area of triangle HEF is what? This plus. So when we add the two, what we get? We'll get a parallelogram or a quadrilateral, that is EFGH, right? So we write over here, this is equal to area of quadrilateral EFGH. Similarly, if we have a look at this part, area of triangle HFCD. HFCD is which one? HFCD. So the top part, okay, this entire part now. And HABF is HABF, this bottom part. So when you add these two together, we get this big quadrilateral, that is ABCD. You can say this is equal to half of quadrilateral ABCD, and that's what we are actually asked to prove, that area of quadrilateral EFGH is equal to half of area of area over here quadrilateral ABCD. There was a half over here which I had not mentioned before, but this is what we are asked to prove, not area of triangle EFGH equal to area of triangle ABCD, not triangle, sorry, quadrilateral, but area of quadrilateral EFGH equal to half area of quadrilateral ABCD. That is what we are asked to prove, and that's what we have finally proved. Okay, so if you like watching this video, hit the like button, please share it with your friends and classmates. Do not forget to subscribe to the channel and click on the bell icon to receive updates. Thanks for watching. See you in the next video.